Okay, this is Mario with MIM Microflight once again, and in this video I'm going to be talking about this quarter scale go-kart, which is modeled after the Alley Cat, popular back in the 60s, 70s. All these dimensions that I got for this particular go-kart come from my own research and kind of eyeballing things and seeing what seems about right. But I got some basic dimensions such as the wheel to wheel, center line to center line distance, the rear distance from the back wheels, also the front, height of the seat, distance from the seat to the steering wheel, from a gentleman that builds vintage racing karts. He reproduces in particularly, he's reproduced the Alley Cat, and he's got some very nice videos. Goes under the name Racing Psychosis. So if you want to look at his work, take a look at his channel. That's where I got some of the dimensions, but like I said, not all of them, and so I had to finagle some of my own dimensions by looking at a lot of pictures. Anyway, this is where I'm at right now. It took me a while to do this because, well, when I say a while, it takes me about a full day of nonstop work doing the. I had to do a bender. I had to 3D print my own bender so that I can bend these in scale using quarter-inch aluminum tubing. And so, and that's an art in itself, trying to bend things and trying to get it right. So you're going to mess up if you're going to attempt to bend a frame like this for the first time, or even in full scale, as the other gentleman talks about. The same thing. You're going to mess up on a few bends while trying to get it just right. And so I did mess up on some bends. I kind of wasted two 36-inch rods while doing that. In doing the full frame as a one piece. That whole section is one piece. That is a one piece. The front tube that does the support for the front axle. That's another little piece. That's another little piece, and I have to yet to do the support for the steering column. So, but these were made from the scrap material that I got left over from the bends that I screwed up, and so it's really not wasted material if you look at it that way. The seat pan is a one-piece aluminum. This is just a 1/32 aluminum sheet that I had. And I just made it, just had enough to do these little curves at the around the frame here. And so right now I just have it set up with these P-clips. These are the P-clips that I use on my radio control ultralights, microlights, autogyros, helicopters. I mean, I've been using these P-clips since I started at my Microflight, and way before them. I used to use these P-clips to support things and to hold things for my radio control models. And so I decided to do the same thing here with this particular go-kart. This particular design was meant to mimic a kart, full-scale kart build with EMT tubing and maker pipe connectors, like I did my racing go-kart, which in full scale, which is in some other videos. And if you want to look at those, you can look at the my channel and find those videos there. And so I wanted to do this particular style using the same method, EMT tubing in the full scale and maker pipe connectors. And so that was my approach here. But I also want to do a welded frame in full scale as well as in miniature. So I've never welded aluminum before. I had these rods from back in the 80s. I think I saw some guy do some welding. He was welding actually soda pop cans, aluminum cans, using these rods and a torch. And he made it look so easy that I ended up buying the rods. And I tried it one time before, a long time ago, and it never worked with me. Well, my wife just got a torch recently from Amazon, and it's a butane torch, and that thing is super super nice. In fact, yeah, that's the torch right there, and I just tried it for the first time, and I make sure that I clean the aluminum really well, as it's suggested in some videos that show you how to do these things. And I ended up with this particular type of weld here. It's pretty strong. You're not supposed to heat the rod itself, but the material, and it's got to be super clean. And you just keep heating and heating and heating, and just let the rod, the welding rod, on the heated part, and it'll flow right in, right on the material. And so I was pleasantly surprised to see that, yeah, this does weld. So, and it's pretty strong. I mean, I put a good amount of force, tension here to try to break this joint here. And even though it's not really welded that well, because I didn't curve the end of this tube, I just took two flat tubes and just tried to joint to see if the process would work. But it does work. So I am excited about that. And so I think I'm going to start with the welding process. I'm going to weld this section here, because this is just attached with rubber bands for this mock-up. As you can see here, that's attached with a rubber band. This will get some plates with ball bearings here for the rear axle. And I still have to finish some additional parts here. I am going to modify the seat a little bit here, because this is a seat that I made from one of the leftover parts that I messed up. And so I kind of undid some curves and redid the curves, and in that process, some of these edges came out kind of ugly. And so I'm going to redo this. I'm going to make it a little more square on the ends, of course with the 8 shape, but a little more flatter at the top. And I'm going to match that pattern onto the front support here, which is very much similar to the way the alley cats, some of these alley cats were done. And so I'm in the process of actually going and rebending the seat and the support here, and I'm going to make this a little bit longer. This is just my mock-up tube that's going to hold the axle in place. It doesn't need to be a complete tube. If I weld just a little piece here, a section of the tube, and a piece here on the sprays here, that's all you need for the steering rod to go through. And the steering rod can be anything from a steel wire, or even just a small diameter tube that can fit inside this tube right here for the steering axle. And so I'm about to do those things, but I wanted to capture this on video and just show you the process that I've been taking, to achieve this little model here. It's not really complete in any sense. It's just like I said, it's just a mock-up right now. But once I weld and I attach everything together, I think it's going to come through. The wheels are just temporary, because I don't have the actual wheels. I do have to manufacture those wheels from scratch, because I don't think there are wheels this particular size that mimic the go-karts, or maybe there is. I don't know. I haven't looked, and so I will do the wheels later on. But that gives me a good representation of dimensions, and kind of just a good reference to go from. I did this on this board. This is where I was doing some preliminary sketches, as I showed in my other video. And this is actually the area that I use, to trace out all the outlines, for the top. I have some views, for the side, and for the front of this front section right here. The steering wheel is there, with the proper dimensions. I have some references here just to the hardware, for the full size, and then the quarter scale size. As you can see, this is the scale 1/4 scale of the Elk Cat. This was very, very difficult to do this curve here, just trying to figure out the curves here. It may not appear so, but when you're using a particular bender and you have design your bender in a certain way, I designed my bender so that I can have the center line of the center line of the radius. In this case, it would be the inner radius, because when you have a pipe, you have three types of radiuses there. You have the inner radius, which is what this washer outside diameter indicates. So that would be the inner radius of this tube here, or pipe. And then you have what they call a center radius, which is halfway the diameter of the pipe itself. So basically just a center line inside that pipe. That would be the center radius, and then you have your outer radius. And the way to calculate the actual length of the pipe that you need to establish that particular bend is given by some formulas, which I wrote down. I mean, I have some here, and I have some over here. So the length of tube bend. Okay, so the length of the tube that you're bending, in other words, this tube, for example, it's got a 90 degree. So you take the center radius times 2 times 3.4, which is pi. You divide that by 360 degrees and multiply that by 90, because we're doing a 90 degrees. And if this was a 45, you take the same formula and you multiply it by 45. And that's what I have here, these values here. So the length of that, at this particular scale, the length of my 90 degree tubes is 0.98125. I rounded that off to 1 inch because it's very, very close. And then at 45 degrees, the length of that curve is 0.4906, which I approximated to rounded it off to 1/2 inch. And so that's how I was able to do all these curves that you see here. And for that particular here, you can see that I have some markings there, and that was just a reference for where to set it on my bender. And my bender is, like I said, my bender is, I have another video that talks about the bender that I did for bending miniature scale tubes. That one is also, before you start bending, so I have to insert the tube about an inch inside the bender where it grips the tube. That's got an inch distance. And so that's my reference point, an inch from where I want to start the bend, and then I start bending. But the problem is that when you're doing a complex bend like this, you need to figure out the distance. I need to figure out where I'm going to start this bend here, because this bend is easy using the 1 inch reference, but this bend right here, where do you start the bend? I mean, an inch from here, it's kind of difficult because, so I had to, turn the pipe around and do some. I still don't have that embedded in my brain just yet, but I'm working on that. And once I get that embedded in my brain, it'll be easy. But until then, I had to play around with this with those curves and distances, and that's why you see all these tubes, from my earlier trials. But I finally got it, as you can see it there. So that establishes the frame. I still have to work on the wheel. This wheel is probably going to be 3D printed, although I do want to use aluminum for the rim. So I'm going to have to work on that and see if I can. For this, I need another die with that particular diameter. The inside the center radius is what you use in the formula to figure out the length, the length of the tube that you're going to need to do the whole perimeter on the wheel. And so I have to plug in that into that formula that I said, center radius times 2 times 3.4 divided by 360, and multiply by, actually I I have to figure that out. I don't think we need to multiply anything, because the 360 is already, well, you're dividing by 360, and you're probably multiplying by 360, so you basically that cancels out. So it's probably just the perimeter, which is the formula radius times 2 times pi. So that will give me the complete radius there. I think I got that right. Anyway, so yeah, this is where I'm at. So I am off to rebend this seat right here, and and do the support for this section here. This is interesting how they did this. These cars, this is I didn't think, before I saw this band here on the real thing via the videos, I just saw this bar here and I go, how the heck are they supporting the seat here? And then I saw the gentleman install the pan and I go, oh wow, that's kind of interesting the way they did this. They just have this bar in the back that acts just as for the back support and is welded, at the particular angle right against this pipe here. And then this pan is actually doing the support of the back as well as the front. So you're sitting and you create a nice support there. However, on the real ones, is that other gentleman that builds the full scale ones talks about. He said that he had to do a brace here because the weak point was here. Well, sure, when you really analyze the weight distribution on this and where the forces are, you have a pilot that's sitting here or a driver with a lot of weight. It's 150, 200 pound person that's sitting there and it's creating a lot of tension right at this point right here. That's going to be your weak point because you're most of the weight is right here and you only have a bar here that's welded to this portion here. So unless you brace this somehow, that's going to be a weak point. What I am going to do is I'm going to sort of bypass that. I'm going to bypass that. Where's my other pipe? I don't have it here. I'm going to bypass the original design. I'm going to put my own touches here. So what I'm going to do is I'm going to create a bar that goes from the back here to the support here. So that supports the seat and reinforces the section here without having to use a gusset here on the sides welded. You can use a gusset and just keep this clean and super open frame. But I kind of like this setup here with these braces here. And that's how I did my racing go-kart, my more racing style go-kart using the EMT and the maker pipe connectors. So I think I'm going to do that right there. And the front, maybe I just leave that open. Maybe I'll do something a little more spiffy here at the front, just to kind of give it a little bit of more of a modern touch to it. Or I don't know. I would be interested to see what people think about it. And would you leave it open? Would you leave it a little more enclosed frame? Let me know in the comments. Thanks for watching.